Section: Introduction. In this section, we delve into the importance of fine-tuning existing large language models, LLMs, for new applications, a practice that's become essential in both research and commercial endeavors today. We have the option to fine-tune open-source language models, like Llama 2, using our own resources, or to use fine-tuning APIs for proprietary models, such as GPT 3.5 Turbo. Many of these models have been through a process called alignment training, like RLHF, to ensure they can understand and follow user instructions while providing useful responses. This training also aims to make them safe, meaning they can handle problematic queries by refusing to assist or by providing safe, constructive feedback. However, a question has emerged: if a model is fine-tuned on datasets that are considered benign or safe, does it guarantee the model remains safe for public use? Recent findings have shown that even when fine-tuned on these so-called benign datasets, models can exhibit an increase in unsafe behaviors. Our paper focuses on identifying the best methods and practices to prevent this loss of alignment. Through our research, we've discovered that the prompt templates used during both fine-tuning and inference are key to maintaining safety. Prompt templates are essentially strings with placeholders that are filled with input data when interacting with the model. For example, Meta's Llama 2 chat models recommend using a specific template that signals the model to respond in an instruction-following mode, rather than generating responses freely. Additionally, appending a safety prompt at the beginning of interactions, which explicitly emphasizes the model's role as a helpful, respectful, and honest assistant, has been a common practice to enhance safety. The challenge arises when there's a shift in the distribution of data between the fine-tuning phase and the inference phase, which can compromise safety. Our experiments with popular public language models have shown that maintaining the same prompt template throughout both phases can actually harm safety alignment. Conversely, using different templates for fine-tuning and inference significantly reduces the attack success rate, ASR, a measure of safety loss, with prompt template safety tuning, PTST, emerging as the most effective strategy. We also explored the impact of adding safety examples during fine-tuning. While incorporating safety examples that mirror the style of safety benchmarks can nearly eliminate ASR, the diversity and creativity of harmful queries mean that a small or moderate number of examples might not cover all potential unsafe queries. Our findings suggest that even with safety examples added, using PTST can greatly reduce safety degradation, highlighting its effectiveness in maintaining model safety even in these scenarios. Section Summary. In this section, we explore the importance of prompt templates in maintaining the safety and alignment of fine-tuned language models. We demonstrate that using different prompt templates during fine-tuning and inference, rather than the same one, significantly reduces the loss of safety while still improving performance on downstream tasks. Additionally, we show that incorporating additional safety examples during fine-tuning can help mitigate safety degradation, with the most effective strategy being PTST even when safety examples are included. Section: Threat Model and Safety Evaluation. In this section, we delve into the experiments and findings of our study, employing specific terminology for clarity. We, the users, start by fine-tuning an existing aligned model using a set of training prompts, which we refer to as the training template. Afterward, we deploy the model for use with a different set of prompts, known as the test template. It's important to note that the training and test templates might be the same or different. We evaluate the model's performance based on a helpfulness metric, which varies depending on the training set. For instance, when using the GSM-8K, grade school math, as the training set, helpfulness is measured by the model's accuracy on the GSM-8K test set. Similarly, for other datasets, helpfulness corresponds to accuracy on those specific datasets. An attacker, who can only interact with the model without knowing its internal workings or the data it was trained on, submits a harmful query using the test template we chose. A judge, which could be a sophisticated language model like GPT-4, then assesses the harmfulness of the model's response on a scale from 1, not harmful, to 5, very harmful. We use a GPT-4 model as a judge to rate harmfulness in our experiments. By analyzing a dataset of harmful queries, we calculate the attack success rate, ASR, as the percentage of queries that receive a harmfulness score of 3 or higher. We acknowledge that it's possible to manipulate even unmodified public language models to respond to harmful queries through careful prompt engineering, a technique known as jailbreaking. However, addressing these jailbreak attacks is outside the scope of our current study, so we focus on evaluating safety against harmful queries that the original model can already defend against to some extent. We introduce a new dataset, Direct Harm 4, which consists of queries from various categories known to elicit higher ASRs in many fine-tuning scenarios. This dataset complements the ADVA bench benchmark, which includes examples of direct harmful requests. Our study also explores the impact of prompt templates on model safety and helpfulness. In a case study involving the fine-tuning of the Llama 2 chat model on the GSM-8K dataset, we examine 5 different prompt templates. We categorize models based on whether they use specific tokens to operate in either chat mode or text mode. Our findings suggest that using the same template for both training and testing can improve helpfulness but may compromise safety. Interestingly, models using chat mode templates generally exhibit better safety than those using text mode templates. We discover that a strategy we call pure tuning, safe testing, PTST, where we fine-tune the model without a safety emphasis but use a safety prompt during inference, effectively preserves safety without significantly sacrificing helpfulness. This approach proves to be more effective than early stopping, a common technique to prevent overfitting during training. Our experiments show that PTST consistently results in lower ASRs while maintaining helpfulness, highlighting its potential as a valuable strategy for enhancing the safety of fine-tuned language models. Section Summary. In this section, we explore the threat model and safety evaluation in our experiments. We investigate the impact of prompt templates during training and testing on model safety. By introducing the pure tuning, safe testing, PTST, principle, we demonstrate that fine-tuning models with safety prompts but testing without them significantly reduces attack success rates, ASRs, while maintaining helpfulness, outperforming traditional early stopping methods. Section. Experiments on other models, GPT 3.5 and Mistral. In this section, we delve into experiments conducted on additional models, namely GPT 3.5 Turbo and Mistral, as well as on other datasets like ChatDoctor and OpenOrca. We also explore the impact of different safety prompts on model performance. Starting with GPT 3.5 Turbo, we utilized OpenAI's API for fine-tuning and inference in chat completion tasks. We adapted chat mode prompt templates for this purpose, making slight modifications such as formatting them as JSON arrays to meet the API's requirements. We fine-tuned the GPT 3.5 Turbo model on the GSM-8K dataset for 1 epoch. The batch size and learning rate multiplier were automatically determined by the API, set to 4 and 2, respectively. Our findings indicated that for models fine-tuned with standard chat templates, switching to a specific template, chat, Llama, for inference significantly lowered the rate of harmful outputs while maintaining the helpfulness of responses. This was evident when comparing the performance of models trained with a standard chat template and then tested with the chat, Llama template, which showed a decrease in harmfulness without sacrificing the effectiveness of the model. In the case of Mistral, we fine-tuned the Mistral 7B Instruct v0.2 model on the GSM-8K dataset over 6 epochs. Our analysis, detailed in the appendix, revealed similar trends to those observed with Llama and GPT 3.5 Turbo. Specifically, employing a particular training and testing strategy, which we refer to as PTST, significantly reduced the harmfulness of outputs while preserving their helpfulness. Conversely, using the same template for both training and inference resulted in a higher rate of unsafe responses. Our exploration extended to other datasets, including ChatDoctor and OpenOrca, where we fine-tuned the Llama 2 to 7B chat model. We adhered to chat mode templates for simplicity and assessed the safety of the models using specific benchmarks. The results from these datasets mirrored those from the GSM-8K experiments, underscoring the importance of not using the same template for both fine-tuning and testing to avoid compromising safety. Switching to the chat llama template for testing, in particular, proved to be an effective strategy for maintaining safety while still enhancing helpfulness. Furthermore, we experimented with additional safety prompts to validate the PTST approach. These included a default system prompt and a shorter version recommended by the Llama 2 paper. Testing these templates on the GSM-8K dataset for both Llama 2-7B chat and GPT 3.5 turbo models showed that using different templates for training and testing preserved safety and retained a significant portion of helpfulness improvement. However, fine-tuning and testing with different safety prompts indicated a noticeable decline in safety, suggesting that the adverse effects of using a safety prompt for fine-tuning cannot be easily mitigated by simply switching to another safety prompt for testing. Lastly, we investigated the potential of enhancing safety alignment by incorporating safety examples into the fine-tuning process, a method previously found to be beneficial. This section explores the effectiveness of combining PTST with safety examples in fine-tuning, aiming to further safeguard against harmful outputs while maintaining the utility of the models. Section Summary. In this section, we experiment with GPT 3.5 Turbo and Mistral models, fine-tuning them on the GSM-8K dataset for chat completion tasks. We observe that transitioning from chat vanilla to chat llama for inference reduces harmfulness rates while maintaining helpfulness, and using different templates for training and testing helps preserve safety. Additionally, we explore the impact of using different safety prompts during fine-tuning and testing, finding that maintaining consistency in safety prompts is crucial for preserving model safety. Section. Adding safety examples can reduce the OSR on similar queries without PTST. In this section, we discuss how incorporating safety examples into training can significantly lower the attack success rate, OSR, on queries similar to those found in datasets like AdvaBench and Direct Harm 4, even without using pre-trained safety templates, PTST. We utilized a dataset comprising 2,483 harmful queries and their safe counterparts for training. These queries share a similar style and format, typically consisting of a single imperative sentence seeking assistance for harmful behavior. This similarity suggests that adding these safety examples could effectively reduce ASRs on AdvaBench and Direct Harm 4. For training details, we fine-tuned the Llama 2-7B chat model using a combination of the GSM-8K dataset and the aforementioned safety dataset. We processed the GSM-8K dataset for 6 epochs and the safety dataset for 1 epoch, with a learning rate of 0.0001, consistent with our previous experiments. We trained the model using 3 different templates: chat, vanilla, chat, and chat, llama, ensuring the same template was used for both the GSM-8K and safety examples. Our results showed a significant improvement in safety, with ASRs dropping to nearly 52% across different training and testing templates. This improvement was observed regardless of whether the same templates were used for both training and testing. Additionally, when PTST was applied, we saw a further reduction in OSR, although the improvement in safety was relatively marginal. However, we found that adding safety data was less effective for out-of-distribution (OOD) queries, which are harmful queries from completely different distributions. To illustrate this, we created a new dataset, GSM Danger, by prompting GPT-4 to generate harmful instructions disguised as math problems from the GSM-8K dataset. These instructions, which encouraged dangerous behaviors, differed significantly in style and content from the safety data. Our evaluation on GSM Danger revealed that the original model performed well, but fine-tuning with the same templates used in testing significantly increased the OSR, even with the addition of safety data. This increase was observed across all templates. However, fine-tuning with PTST showed more promising results, demonstrating its effectiveness in reducing OSR, especially when different templates were used for training and testing. In the context of related works, we explored the role of prompt engineering in aligning large language models, LLMs, with human values. Before chat models became prevalent, prompts that combined instructions with in-context examples were used to elicit honest and harmless responses from LLMs. This approach was later adopted for chat models, where prompt engineering alone was found to enhance safety. Some studies reported that the safety of Llama 2 chat could be improved by adding a safety system prompt, and employing self-reflection prompts could further enhance safety. However, the impact of using different prompts for fine-tuning versus inference has not been thoroughly investigated. We also reviewed studies on the safety risks associated with fine-tuning aligned LLMs. Recent research has shown that fine-tuning on a small amount of harmful data can bypass safety guardrails, and fine-tuning with unsafe data can lead to safety degradation. Interestingly, fine-tuning with benign data can also result in safety degradation. These findings highlight a gap in aligning the fine-tuning process with specific utility-driven objectives. Our experiments with fine-tuning Llama 2-7B chat on the Alpaca dataset did not show an improvement in instruction following ability, as measured by Alpaca eval. We encourage readers to refer to additional related works for more insights into the challenges and solutions for enhancing the safety of LLMs.